del simposio Ambiente y Bioenergía 2022. Vamos a dar paso a nuestro primer panelista del día de hoy, al Dr. Bikash Kumar. Él es investigador postdoctoral del Instituto Indio de Tecnología de Guwahati y se licenció en biotecnología en el Departamento de Biotecnología de la Universidad Central Guru Ghasidas de Bilashpur y tiene una maestría en bioinformática en la Universidad de Pondicherry. Recibió la beca Jawaharlal Nehru para estudios de doctorado del Fondo Conmemorativo Jawaharlal Nehru, Nueva Delhi, India. También ha recibido el premio CSIRF Direct del Consejo de Investigación Científica e Industrial de Nueva Delhi y la beca de investigación de verano de INSA, India. Le dejo con ustedes al doctor Héctor Mario Pollo Ibaraldo, quien será el moderador de esta charla. Muy buenos días a todos y bienvenidos.
Muchísimas gracias, doctora Paula Sotelo. I'm going to read the brief biodata of Dr. Bikash Kumar. He is a postdoctoral researcher at the Indian Institute of Technology, Guwahati. Dr. Kumar holds a Bachelor of Science in Biotechnology with honors from Guru Ghasidas Central University at Bilaspur. He also completed his Master of Science in Bioinformatics from the Bioinformatics Center at Pondicherry University in India. He has established a state-of-the-art microwave-assisted salt pretreatment approach and in-house enzymatic hydrolysis system for the valorization of lignocellulosic biomass. So far, Dr. Kumar has contributed 17 articles and 14 book chapters in edited books. His work has received nearly 1,000 citations, and Dr. Kumar holds an age index of 15 according to the Google system in just 5 years of research work. Dr. Kumar is also the recipient of the prestigious Jawaharlal Nehru Scholarship for Doctoral Studies. He has also received from CSIR a direct award for high research activities. Also, he has received several summer research fellowships from INSA, India. It is a great pleasure to invite Dr. Kumar to address his guest conference entitled Cellulases from Schizophyllum commune, in-house improved production, characterization, and evaluation of their biorefinery potential. Thank you, Dr. Kumar. You can start your speech.
Thank you for the introduction, and I thank the committee for inviting me for the talk. And I will update my bit biography that I will be joining as National Postdoctoral Fellow at IIT Indore in the coming 10 days. So this is the only update I would like to change in the biography part. However, coming to the presentation, the cellulases from Schizophyllum commune. We will talk about a beautiful Schizophyllum commune, which result in production of several enzymes, including cellulases, and we will we targeted around for the production, characterization, and its application in the biorefinery. And we will, I will be presenting a small review of the work and would present the contributions and the findings. So coming to the, so basically the work is designed with the focus of biorefinery concept, where the biomass is first pre-treated with the microwave pretreatment system. It is a separate part of the work, and the second part was the production of cellulase enzyme using Schizophyllum commune and its characterization, production, characterization, and its application in the biorefinery using the pre-treated biomass and untreated biomass. It will be tested with different cocktail of xylanase as well for the breakdown of the hemicellulosic part, which is received after the microwave pretreatment. So the work in science, when we start working, we always discuss about why there is need of a work. We need to highlight the problems associated with the topic. Then we will approach how we are going to approach the problem and what can be obtained during what we obtained while performing different work and the observation and inference we made during the work. So based on that, I will just brief a small about the lignocellulosic biomass consists of a lignin, hemicellulosic, and cellulosic component. Here we target on the cellulosic part. So this component is broken down by the cellulose with the help of endonucleases, endoglucanases, and exoglucanases. And hemicellulose is broken down by the group of enzymes called xylenases. So in the last part of the work, we will discuss about the cocktail cellulase-xylenase cocktail. However, the most part is considering the cellulase biorefineries only. So what are the different agro-residues? So while approaching for the biorefinery, we need to assess where there is availability of the agro-residues. Yes, there is a lot of available biomass because there is increase in population, and the increased food production has resulted in generation of huge amount of waste agricultural residues, including food crop, non-food crop. And so the biggest question arises, is the enough biomass available? Yes. In terms of our work, we focused on rice, sugarcane, wheat. So here we can see that it has a huge amount of production wide, and India as well. So India is ranked among second and third for the rice, sugarcane, and wheat production respectively. So in the biorefineries, the process involved, biomass is first collected and pre-treated, and it is subject to the pre-treated biomass is subjected to enzymatic hydrolysis. Then it is fermented using ethanologenic microorganism. Then it is recovered and distilled. So the main rate limiting steps in the biorefineries are the pre-treatment and enzymatic hydrolysis. So in our work, we will be discussing more about the enzymatic hydrolysis part. Not pre-treatment is a separate section. In the application part, we will brief small about this topic. So why there is requirement of cellulase search? There is requirement of highly efficient and stable enzyme during varying and harsh environmental condition, which the biomass went through during the fermentation and the recovery process. So what does cellulose do? Cellulose and hemicellulose are complex sugar which are available after pretreatment. Cellulases cannot be directly converted to ethanol or biofuel due to its complex structure. So cellulase primarily constituted of a group of enzymes which acts synergistically in order to depolymerize celluloses. So it is endoglucanases, cellobiohydrolases, and beta glucosidases. So endoglucanases and about cellobiohydrolases, these are considered to break the act on internal beta-1,4 glucosidic chain and sleeve it generate long chains of oligosaccharide, cello-oligosaccharides. Then acted upon by the cellobiohydrolases, it results in the formation of cellobiosis or other oligomers, which is then subjected to beta glucosidase, that is side chain. It cleaves the glycosidic bond beta D glucosides, and thus acting on synergistic action of endoglucanases, cellobiohydrolases, and beta glucosidase, then cellulose is converted into glucose monomer. So there is need of cellulase enzyme for conversion of biomass to biofuel. So cellulose application may reach around 2.3 million into 10 to the power 3 million USD by 2025, because there is beside biorefineries, it has application in textile, food, and other processing industries as well. Several market players are Novozymes, DuPont, and Roche, and it covers around 75% of the total market. So commercial enzymes are costly, and only few companies produce enzymes that have monopoly on enzyme market, thus keeping very high cost. So enzyme was suggested to be produced in-house. It will have two benefit. It can be because in our work we showed that biomass can be used for generation of cellulase enzyme, and it can be further utilized for the in-house application in the biorefinery or other sectors as well. So major limitation with the cellulase enzyme production is substrates. Commercial substrates are very costly, low enzyme yield, low stability at high temperature and pH, and multi-step purification step leading to enzyme loss during recovery. So here we will use a cheap substrate, and then we propose to have a high yield with stability at high temperature and pH, which are harsh industrial condition, Then multi-step purification step is reduced to a single step purification step, which will be discussed in the later part of the work. So the basic hypothesis is this, so which I showed in the work. So how we plan to do it? We did the microbial assisted treatment. The pre-treatment part was separate from the enzymatic hydrolysis part, but it was merged during the enzymatic hydrolysis and the fermentation stages. So we will discuss more about the in-house enzyme production and purification and application in the in-house cellulase and xylanase enzyme. We produce xylanase enzyme from Aspergillus niger, Aspergillus oryzae, and for the production of oligosaccharides from the treated biomass. This is the additional application of the produced enzymes. So basic methodology, we isolated the Schizophyllum commune from Lantana camera plant, Lantana camera from Chachar district in Assam, India, northern part of India. We then tested 4 different media, which is already available in the text, that is Zepedox broth, vessel salt media with wheat bran, then CMC synthetic liquid media, and Mendel's and Sternberg media to screen out the best medium out of it. So for the screening, we used 4.35 into 10 to the power 7 spore per ml for 7-day-old culture, incubation at 28 degrees Celsius, 100 RPM, and samples are drawn at 24 hours to check the enzyme activity. Cellulase activity were determined using CMCS, 1% CMC, and FPS using 50 mg Wattman filter paper. Then 5 different substrates are used for the cellulase production using the selected medium. So to summarize here, I will say that MS media, that is Meldon and Sternberg media, was found to be suitable. Then we substituted the carbon source, that is glucose, with the sugarcane bagasse, wheat straw, rice straw, wheat bran, and rice straw, and check the efficiency of different waste for the production of cellulase. Then based on selection of the treatment, we found wheat bran as the best substrate, and we used for the statistical optimization. So based on one factor analysis, we found wheat bran, magnesium sulfate, calcium chloride, and temperature and pH to be efficient factors, and we chose the range from the one factor analysis, and we set the CCD RSM using Design Expert Software 9. So statistical analysis and modeling was performed, ANOVA, and further validation was performed, and it was used for enzymatic hydrolysis of transition metal salt, pre-treated rice straw, and also the unpurified. Then purification was also performed using cellulase 5 different methods, that is ammonium sulfate precipitation. We have done a single step purification, separate ammonium sulfate, anion exchange, then gel filtration, ATPase with Tritonex 114, and ATPase with PEG and MnSO4. So we performed a comparative analysis based on enzyme activity, protein specific activity, and yield. Then after we found ATPase with PEG MnSO4 as a best method, and we subjected it to the protein was subjected to HTS page enzymography for confirmation of the protein size. Then thermal and pH stability was analyzed. Application for cellulase and xylanase hydrolysis of rice straw was performed, and the hydrolysis sample was subjected to TLC. Application of purified cellulase for enzymatic hydrolysis of the pre-treated and untreated rice straw, and different generation of value-added compounds was checked. Further, simultaneous saccharification and fermentation of the pre-treated rice straw, using different system, was subjected to simultaneous saccharification and fermentation using this cellulase enzyme and enzyme xylanase cocktail as well. So ethanol and oligosaccharides were confirmed using HPLC analysis. So starting from the selection of media. So coming to the selection of media, we checked 4 different media. Here we can see M4, that is Meldon and Sternberg media, showed the best activity, and it reached to around 7th day, the highest activity is of 10. Then when this M4 media was subjected with 5 different agro residues, we saw where the carbon source was replaced with wheat bran, rice straw, rice husk, wheat straw, and sugarcane bagasse. We clearly see wheat bran showed highest activity, followed by sugarcane bagasse, rice husk, wheat straw, and rice straw showed the minimum cellulase activity using this as a substrate. So after this, wheat bran was selected, M4 media was selected based on this experiment. Then it was subjected to CCD RSM analysis and clearly shows the experimental value of the 6 run, showing experimental value of 169.98, which is predicted and close to 153.70. And also the CMCS activity of 96.72 was obtained, which is close to predicted, so even higher to the predicted values. So CCD RSM, this contour plots were prepared, and it can clearly see the CMCS activity. Change in pH around 5, it showed the maximum activity. With the CaCl2 activity, similarly, we saw with increase in CaCl2 concentration, it increased with cellular activity. When compared with the wheat bran and temperature, keeping other factor, that is CaCl2 pH as constant, we can see that there is increase up to 35 degree, but after that there is decrease in activity. Similarly, for the wheat bran as substrate, we can see with increase in of the nutrient physical parameters. We checked that run 6 and run 24 showed best activity for FPAs and CMCS activity respectively. Then we found it is very close to the predicted values. So similarly, for the optimization of the nutrient and physical parameters, we did using the design expert software, we retrieved this contour plots, and it's clearly suggested that the with change in pH, CaCl2, and keeping other parameters, that is wheat bran temperature and MgSO4 concentration, clearly shows that all the parameters which we checked are evident with CaCl2 temperature and wheat bran concentration to be the most efficient factors to be affecting the experimental setup. So based on ANOVA analysis, we found that the p-values was lower than 0.05 and shows that CMCS and FPA's activity to be significant based on the plot. And these are the experimental equation we got. So based on the adjusted R square values and R square values, the experimental model clearly explained the 97% of the CMCS activity variation and 87% of the FPA's activity changes. And that was obtained above 11. So further, we the best result, that is run 6 and run 24. Based on that, we selected 1% wheat bran concentration, 0.3 gram per liter MgSO4, 1 gram per liter CaCl2, 25 degrees Celsius, and pH of 5 for the optimum condition. And we checked with and found that 96.72 plus minus 1.4 international unit per gram per ml and 169.98 plus minus 2.55 international unit per ml. CMC is an activity which was very much close to the predicted values of 93 and 153. So, which clearly shows the CCD-based RSM considered as accurate and reliable method for optimizing the cellulase production. So, based on that, we already knew that shaking system that using the for the fungal system shows higher efficiency. So we didn't took one of the parameter, and we shake the sample cellulase production at 100 RPM, and we found that the CMC's activity was doubled and FPA's activity was increased to 1.5 fold, which is around 5.3 fold and 6.62 fold as compared to the CMC's and FPA's activity was obtained with the unoptimized media using the wheat bran as substrate, that is 36.46 international unit and FPAs of 37.01 international unit per ml. So 4 different pre-treatment purification strategies was checked, that is ammonium sulfate precipitation, anion exchange chromatography, gel filtration, ATPase with Titonax, and ATPase with manganese. And we clearly shows that ammonium sulfate precipitation and anion exchange shows poor yield and purification fold, however increased, but the yield was poor. When compared to gel filtration, ATPase and ATPase with manganese sulfate, they showed efficiency of purification fold of 3.7 with 72.8% yield. Similarly, ATPase with Tritonax showed 79.2% yield with 7.24 fold purification, and ATPase with manganese sulfate showed the best result, where 22.5% salt, 11.3% polyethylene glycol was used to give the highest yield of 79.5 with purification fold of 10.4%. So SDS page enzymography was performed. Here we used the Congo red dye in the gel, and we found that a clear zone was found at around 60 kilodalton in both the Congo red and the blue commercial blue segment, and we confirmed the molecular weight of the protein. So as the thermal and kinetic parameters were very crucial for the enzyme to be used in the biorefineries, we checked the variation in temperature, pH for the activity of enzyme. With the relative activity we saw, it clearly shows that with increase in temperature for the most of the activity, around 50% of the activity was conserved up to 24 hours, which is suitable for the saccharification of the biomass. Similarly, in the temperature range of 25 degrees Celsius to 65 degrees Celsius, which is a long temperature range, and for the pH 3 to pH 10, that is acidic and alkaline pH, we saw that the, around 50% activity was conserved in all the system, with almost 100% in the pH 6 and pH 8. So we can say that high range, the enzyme was active in wide range of temperature and pH, and can withstand the industrial conditions and suitable for the biorefinery as well. So based on kinetic analysis, we found very low Km, that is 0.09 mg per ml, and high max Vmax of 45.45 unit mole per minute per mg for the substrate used. So we performed the hydrolysis of the rice straw and wheat bran using commercial cellulase, in-house cellulase, in-house xylanase, cellulase and xylanase cocktail, which is obtained in-house. It clearly shows that with increase in temperature, this shows the increase in timing for the rice straw and wheat bran. This is the result. So it is give comparable result in both rice straw for all the enzymes for the sugar analysis, and it is confirmed for the using TLC analysis. Similarly, for the wheat bran, we can see the however yield is lower as compared to rice straw, but it also gave increase in sugar with increase in the hydrolysis time. So as I explained in the previous slides, that we will be targeting the hydrolysis of the microwave assisted pretreated rice straw, that is with the chemical FeCl3 and H3PO4. We clearly saw the peak for the ethanol, which was based on the work by the Nisha et al. 2020. So we obtained around 5.6 gram per liter of ethanol based on the area under the curve. Similarly, as I explained, in the crude cellulase, commercial cellulase, crude xylanase, commercial xylanase, crude cellulase xylanase cocktail, and commercial cellulase xylanase cocktail was used for the enzymatic hydrolysis and ethanol generation, simultaneous saccharification and fermentation of COCl2, NiCl2, CrO3 pretreated rice straw using the microwave system, and we obtained that maximum yield of 14.39 gram per liter and comparable yield of 12.41 gram per liter obtained for SSF. So similarly, we can see that with the commercial, we got the maximum yield. However, the crude enzyme, which we obtained in-house in combination with the xylanase from Aspergillus oryzae, we saw the good yield of 12.41.033 gram per liter using the SSF fermentation technology. So the fermenting bacteria fungus was Saccharomyces cerevisiae MTCC 173. So it is comparable to the result by Ramados and Muthukumar. So as we said, the value-added product generation was also tested. We obtained cellobios using cellulase obtained from our work. So the glucose concentration of 1.162 mg per ml was obtained, which was much For the untreated, it is 1.2 gram. When compared to the microwave pretreated, that is FeCl3S3PO4 system, we obtained 7.8, and which is around 6 times more than the untreated. So pre-treatment and in combination with the cellulase definitely increase the sugar yield. So similarly, we obtained xylotetrose for the FeCl3 system using in-house cellulose, in-house xylanase, and commercial xylanase. So small quantity of different oligomers were obtained for the chromium, nickel chloride, and cobalt chloride sample as well. We obtained xylotriose, tetrose, and pentose using the crude xylanase, which was not obtained like NiCl2 resulted in generation of X4 using crude xylanase, but the commercial xylanase resulted in the not showed any xylotriose, tetraose production. Similarly, for COCl2 system, xylopentose was not obtained, and for untreated, xylose tetrose was not obtained using the commercial xylanase, whereas in all the cases of the system, the in-house produced xylanase was efficient in generation of oligosaccharide using the transition metal salt pretreated dry straw. So the major research outcome are wheat bran selected as suitable substrate replacing commercial CMC as a cellulase producing medium. CCD-RSM approach was used for the optimization of cellulase production medium component such as wheat bran, magnesium sulfate, and calcium chloride, and physical parameter, that is pH and temperature. Optimization resulted in increase in enzyme production by 6.62 fold. ATPase using PEG 8000 and MnSO4 system selected as a single step purification approach, resulting in 10.4 fold increase in activity with 79.5% yield. Purified enzyme shows more than 55% of relative activity after 12 hours of incubation over a wide range of temperature, and pH, low Km and high Vmax was obtained. Enzyme was efficiently able to hydrolyze untreated and micro pretreated dry straw and untreated wheat bran, confirmed by TLC and HPLC. Simultaneous sacrification and fermentation using in-house cellulase xylanase cocktail and yeast resulted in ethanol yield up to 12.41 gram per liter. And coming to the crux of this, which I summarized beforehand as well. So reducing sugar was generated, ethanol was generated, and oligosaccharides that such as X3, X4, and X5 and cello oligosaccharides were generated using the in-house cellulose xylanase with the microwave pretreated rice straw. So we developed an in-house cellulose production and purification strategy along with cellulose enzyme and value-added product generation. So I would be open to answer any queries, and thank you for the opportunity once again.
Oh, there is no warning of 45 minutes, Dr. Kumar. Thank you very much. It was a wonderful and comprehensive presentation, very clear. I'm asking to write questions in the chat. I have one question. At industrial level,
okay,
how at the industrial level, how complicated would be the purification of cellulases?
Actually, when we do purification at the lab scale as well, if we go for a multi-step purification, which is common trend, that is first we use the ammonium sulfate precipitation for the fungal system enzyme, and then we subject it to the either gel filtration or anion exchange chromatography. Rather than going for it, we have selected only single step purification, that is ATPase based aqueous two-phase system, that is a single precipitation system where we can found the protein in a different phases using the MgSO4, or different other salts are also tested in the other combinations. We have checked other which I have not shown here. We have checked different manganese, magnesium, and other salt. Calcium salt are also tested, but when we move to the industrial scale, this one step purification will be very helpful, because with increase in the steps, the loss of protein is observed. With the high efficiency of purification efficiency of around 79.5% and fold increase in enzyme activity, that is specific activity is around 10.4, which can be very helpful at industrial scale as well. The complication would be definitely using first we need to reuse the salt, because we have tried and we achieved also some success in that we can reuse the salts again by recovery after the precipitation and the other processes. So the process will be a bit complicated, but a single step purification, in terms of purification, it will not be complicated. In order to manage the cost of the process, we recover the salt or PEG. That can be a bit complicated, but the enzyme purification will be easier with the single step purification approach.
Thank you very much. I wrote the question that I will ask you in order not to be confused by my accent.
No issues, no issues.
You know that whenever you have response surface methodology,
Okay.
Sometimes you want to know the simultaneous maxima of two or three response variables.
Okay.
Let's say
So,
the common ground, and then
yes.
For doing that, some softwares, they have the desirability analysis feature. Did you have the opportunity to perform a desirability analysis for identifying the simultaneous maxima of the two main response variables that were, according to what I remember, FPAs and cellulase activities? Did you have the opportunity to run desirability analysis?
I got your question. Thank you. Actually, we have not separately performed desirability analysis. However, we clearly checked that different FPAs activity and cellulase activity for both the system at different runs. We have checked separately and compared with the experimental and the predicted values that obtained from the CCD-RSM tool. But separately, we have not performed, but it's a good suggestion. I can definitely, in the future work, we can perform this, and it will be very much, what do you call, it provide a common ground for the analysis part, definitely.
I have a second question. Do we have any question from the audience with the yellow hand? Do we have any question from the audience with the yellow hand? Because in the chat, I only had these two questions, and the third one from my side also. What are the typical contents of hemicellulose in the agricultural residues that you tested? I recall rice straw, and the second I don't remember the second one, but you have at least two residues, and then
wheat bran. Wheat
bran. Okay. What are the typical contents of hemicellulose? Around, approximately.
We have checked for the xylose.
Xylose.
Yeah.
Do you intend to perform similar protocols and experiments to obtain hemicellulases, silanases, and so on, in order to complement the action of the cellulase?
We have checked the cocktails for the efficiency of conversion of pre-treated rice straw to the sugars, which we converted later to the ethanol. But as we speak around, we have a different set of group that is working with the xylanase enzyme in our laboratory itself. So they perform the xylanase part, and we are doing the cellulase part during my PhD. So the most of the work was during the PhD. later on in postdoc, actually I'm working on a different project. So I didn't got the opportunity to work on the same project, which is working in the lab with a different student. For the work wise, we are trying, we are doing in the lab, but as per my work, my work is not focused on that part. But definitely in the future, I can work on the when I'm working with my project, because these are the postdoctoral work is on the cellulase production, but it is using a recombinant enzyme. It is a different approach.
Thank you very much. Do we have any other questions from the audience, from the hosts, from the staff? Well, on behalf of Dr. Sotelo and myself and the organizing committee of the symposium, it is a great pleasure to present the diploma of participation that acknowledges your contribution as a guest speaker in the Symposium Environment and Bioenergy 2022. We appreciate very much your collaboration, outstanding collaboration, and we look forward to your future participation in the 7th International Symposium on Environmental Biotechnology and Engineering 2023 in France, and our symposium in 2024. Thank you very much. This diploma will be sent by email to you as soon as the symposium ends.
Thank you very much for the moderators and the committee members of the organizing committee of the conference for providing me second opportunity, and I will be definitely happy to be part of the conference in the future as well. Thank you very much.
Keep up your excellent work.
Thank you.
Thank you very much.